Welcome to the last lesson, 12.6, slope fields. If you made it this far, good job. This is the last new lesson. What comes after is the review for the final. So let's say we have a differential equation, dy over dx equals x plus y minus xy. What does the slope look like for different x and different y? Let's complete the table on the right. When x is negative 1, y 0, then the slope will be negative 1 plus 0 minus 0, which is negative 1. When x is negative 1, y is plus 1, we will have negative 1 plus 1 minus negative 1 times 1. So that's negative 1 plus 1 minus negative 1, so that gives us 1. When x is negative 1, y is 2, we would have negative 1 plus 2 minus negative 1 times 2. That's negative 1 plus 2 is 1, plus 2 is 3. When x is 0, y is 0, well, that's just 0. 0 plus 0 minus 0. When x is 0, y is 1, that's 0 plus 1 minus 0, that's 1. X is 0, y is 2, that's 0 plus 2 minus 0, that's 2. When x is 1, y is 0, that's 1 plus 0 minus 0, that's 1. We can keep doing this, and we will this table. We figured out the slope of y prime at all of these points. Once we have that, we can sketch what's called a slope field. So for example, at negative 1, 0, the slope is negative 1. So I can draw a line like this. At negative 1, 1, the slope is positive 1. At negative 1, 2, the slope is 3. At 0, 0, the slope is 0. At 0, 1, the slope is 1. At 0, 2, the slope is 2. At 1, 0, the slope is 1. At 1, 1, the slope is 1. At 1, 2, the slope is 1. At 2, 0, the slope is 2. At 2, 1, the slope is 1. And at 2, 2, the slope is 0. This is going to give us a slope field. Let's call it a slope field. So starting with these coordinates, we end up with a slope field like this. The slope field enables us to draw conclusions. For example, if we know that x is negative 1, y is 1, then we can start here. And we can follow our line. It goes up even faster, like that. Now it's easier with a larger slope field, so here we go to Desmos. Here we have the slope field for the same function, but it's much larger. Okay. We want to sketch the solution curve through the point 1, negative 1. So let's say that we know that this differential equation is true. D of y over d of x is x plus y minus xy. We also know that 1, negative 1 is a solution. So we start here, 1, negative 1. Actually, let's draw it on here. 1, negative 1 is a solution. Nope. That's negative 1, 1. We want 1, negative 1. We just follow the slope field. This is going up, and then it goes up faster, and that's still going up, but now it's going down, so it just stays right there. There we go. That's our solution curve. This tells us if we start here, if x is 1, y is negative 1, after some time, it's going to get to around 2, 0, and then 3, 1 point something, and so forth. And then y will stay about constant over time. So slope fields can help us analyze the behavior of the function using the slopes at different points. That's it for slope fields. Really for the MCAS, not MCAS, really for the AP test, you should know how to sketch slope fields. And you should know, given the slope field, you should know how to sketch solution curves. Okay.